So yes, quick talk on empathy. Empathy is really important. I've done this as an open space at a couple DevOps days this year. We can do it again this afternoon, but you really need to get the whole empathy conversation, and a lot of people tell me this is hard. So have you ever seen someone shot by an arrow? It is not a fun thing. Has anybody in here been shot by an arrow? No. I've seen someone hit with a javelin before. It was pretty rough. But we get that hurts, right? So if you've been shot by an arrow, you can better relate to what it's like to experience that pain, right? And this is kind of like empathy. There's a difference between sympathy and empathy. So sympathy is feeling pity and sorrow for someone else's misfortune, but not really being able to experience the pain that they're going through. So you can feel sorry for someone, but not really understand, that's bad, but why is it bad and how bad is it? Empathy is a little bit different, where you can understand and share that, where you can put yourself in their shoes, and it's not so much about how it's making you feel, but understanding their perspective on the situation, which is a little bit different. I'll take sympathy and empathy. What we want to avoid is apathy, which is really not giving a damn at all. We need everybody to give a damn. If you're apathetic at work and have people who really just don't give a shit, it's not going to work out. DevOps is not going to happen in your shop. I can guarantee that. Who gives a damn? Anybody? Yeah, we got a few people. Yay. So this is kind of the empathy cartoon you see on the internet a lot, but it's I know exactly how you feel. And usually what happens when we get talking about the arrow conversation, empathy around open space, is that, so I should shoot myself with an arrow, like we should all get shot with arrows, this is gonna help. No, but if you've taken an arrow to the knee or been through something, you know what that's like, and maybe this person probably could use a glass of water right now. That would help them feel better. Your mouth gets dry when you got an arrow. So, story time. Once upon a time, guy was stuck in a pit. It was not fun. Anybody recognize the scene here?
Princess Bride.
Has anybody been stuck in a pit before?
Princess Bride.
So, the albino does have sympathy for Wesley in the pit, but it doesn't do him a lot of help. He's like, this is gonna stink. You're gonna get tortured. Don't even think about escaping. Sucks to be you, right? Like, he was a bit sympathetic, but not that concerned. And there's this academic guy that was interested in researching him, and he was apathetic about his plight. Really didn't care. He made things worse, actually, but he was there to study. Experiments can be bad in this way sometimes, right? And then you've got this other guy who's intentionally malicious, cranked the thing to 11, and nearly kills Wesley in the pit of despair. But it doesn't. Wesley's pretty tough. And he did have friends he could count on that did not give up on him, right? Which is important to have a crew. You got a crew, that's clutch. And the reason they wouldn't give up with him and they could stay focused on the task at hand is because they empathize with love lost, right? Inigo Montoya lost his father. This was something, he loved his father. It was a bad problem. Wesley had lost Buttercup, which is why he was going about doing what he did. So he could empathize with him and wanted to help him. And so could Miracle Max. Miracle Max there's not a more noble cause than true love. It's the greatest thing in the world besides mutton, lettuce, and tomato sandwich, if I remember the movie correctly. And there's a big difference between mostly dead and all dead. So they're able to help them bring Wesley back to life, and they go off to storm the castle with Fezzik, also known as Andre the Giant, right? And this ends up working out well, right? Wesley ends up getting back together with Buttercup, and they look pretty happy there. Could be doing worse, like being in a pit or having an arrow in your knee. Inigo Montoya, he gets to take revenge for the five-fingered man who killed his father. He becomes the new Dread Pirate Roberts and takes Fezzik on as his first crewmate, so they all come out well. And if you don't believe me, that's how empathy and team, and it helps improve teamwork, helps people work together, because I understand where their pain's coming from. You can ask Fred Savage if you don't believe me. And I hope you all have seen The Princess Bride, or this probably didn't make a whole lot of sense. And that's the end. I think it'll work. I don't think it takes a miracle. Just gotta try. So, thanks, y'all.
You didn't say spoilers once.
Who hasn't seen The Princess Bride? I'm really sorry.
Dun, dun, dun. Hi, so I'm here to talk to you about scaling DevOps. That's either yay or yikes. So that's what we're going to talk about. So the idea here about the talk is there's a lot of scaling discussions happening. We even had a little open space about it, trying to figure out if it's a good idea or not. So some things that work on a small scale, right? You have farms, you have fishermen. These were things that people did, and they worked very well, right? You'd get food, you know where your food is coming from, you have a relationship with your supplier. But when we tried to scale them, because we thought, oh, if it's a good idea on a small scale, it'll be an even better idea on a large scale, well, they were disasters. So what you're seeing here is factory farming and factory fishing, right? So the idea here is not everything on a small scale may work on large ones. So the question we have, or at least I have every day is this true for DevOps? In other words, can it truly scale without losing its level of integrity? So let's find out. So you guys know about calms. So the first aspect of DevOps we're gonna look at is culture. What does culture look like when it's just a small team? And by small team, I mean anywhere from a working team of about 7 to 10 people. Well, on a small team, right, the team tends to be a lot more autonomous. There's a diversity in skill set because it's just you guys, right? We all have to share in the work. Information travels very quickly, and communication tends to be very informal. But at a large scale, although you have potential for growth because you can take on different roles and you can leverage economies of scale, the trade-off is you have large meetings and you lose autonomy, and sometimes you lose self-direction. So let's look at the automation aspect of DevOps to ask the same question. Didn't time my pause well. Man, this one's longer. Okay, so at a small scale, right, when you think about automations and even configuration management, you have few environments to deal with, right? So just less complexity in general. You have fewer handoffs between dev and ops, and so as a result, you can literally talk to the developer about what you can automate. At a larger scale, right, you have to deal with multiple specialized environments. There tends to be very formalized processes that you need approval for, and there's a lot of potential for conflict. Some of those are merged, some of those are other conflicts. From a learning standpoint, again, we're asking ourselves the question, what happens if you scale learning from a DevOps perspective? Can it work? So from a learning standpoint, learning is quite easy at a small scale, right? You tend to focus more on peer reviews, right? You get to pair. The coaching model is very one-on-one, informal, and lunch and learns are your primary method of learning, and a lot of osmosis, right? Because you're sitting together, information sort of disseminates. But at a very large scale, those things get replaced by formal processes like code review committees, and parenting rarely happens, right? And there tends to be very formal reviews that are tied to your performance. So that's the learning aspect of small versus large scale. So from a measurement aspect, what does it look like? So at a small scale level, measurements, again, tend to be super informal. They tend to be based on whether or not we've deployed working software. There's a low TAT stands for turnaround time, so you can measure your turnaround time very quickly, and there's a clear mapping of business value to output. Your tools tend to be very lightweight. However, at large scales, those things get replaced by project statuses that tend to mean nothing, like you're 90% done and that means nothing in the grand scheme of things. Tools get the name enterprise in front of them, which is hilarious because what does that even mean? So as a result of these things, when we look at these factors, the question still remains, should we despair or should we have hope? Should we think that DevOps cannot scale as a result of these factors? Well, I think that what it will take to scale is to keep the spirit alive. In other words, attack the silos, right, not the people, and organize intentionally, whether it be by feature teams or by value streams. Keep your tools lightweight. Don't buy something because it's called enterprise. You'll get the list if we download the slides of the rest of the things. And what can you do with this information now? Well, first of all, do some research. Find out DevOps at scale. There's a lot of scaling models that exist out there that you could learn about. And that's me. Let's talk. That's my contact information. Bye.
Hello. I have the microphone again. How many of you are ever on call for anything? Whoa, lots. Who's on call right now? Okay, all right. So this will be sort of for you SRE and on-call people out there. Maybe we'll get a little empathy for the rest of the group who's not on call. But we're going to be talking about tips and tricks to reduce TTR for your next incident. And TTR is time to resolution. It also could be time to repair, time to recover. A lot of people do kind of interplace those two or those words, but essentially what we're trying to do is lower our TTR, lower our mean time to resolution. And somebody who's been on call for a long time as part of their career, like they watch these metrics very close. But many of us who aren't on call probably only know the first phase of being on call or the first phase of the incident lifecycle, but actually there's quite a bit that goes on when you're on call. Getting paged or being alerted is just step one, and actually it's only 5% of the total time that it takes you to do most of this stuff. These are some numbers that came out of the State of the On-Call report from that VictorOps did last year, and you can see 5% is just the alerting phase, which is really just step one. Once you've been paged and you've been woken up in the middle of the morning or the middle of the night or whatever, now you actually got to go get things done. And so the point of this is here that used to we had pagers, now we got mobile phones and all these different things, but you're going to get these alerts in the middle of the night. And so what I've got here, Victor, my man Victor here, he's got some different tips. And the first tip is get some custom notifications. If you're just going to get like a regular old text message or an email notification, that's going to be hard to differentiate that from a real problem. Second, if you can include some like context in your alert, that's going to help you reduce that time to resolution as well. The next stage is triage. So this is where you're trying to figure out who needs to be looking at this stuff. Maybe I'm on call, but I'm not really like a networking expert, and the network is what's on fire right now. So you want to start doing different things to expedite that triage step. One way of doing that is to have like a single source of truth, some sort of timeline, whether that's in your HipChat or Slack or something, or if you're using VictorOps, like you've got one place to see it all. The investigation phase is actually the biggest part of being on call. This is where you're going to SSH into your box, you're going to start looking at logs, you're going to check graphs, you're going to do all kinds of things to actually understand what's going on. And that's 40% of your time. So this is where you need to get with the right resources, you need to be able to connect with the right people. And then we heard this yesterday from John at Living Social, like collaborate, share, communicate. Those are really, really big parts of being on call and reducing that TTR in general. The identification phase. So this is where everything will be better if I can just fix this one thing, but how do you know what needs to be fixed? So finding different ways to speed up the identification process is going to be huge. So if you can have some different ways to maybe automatically include wikis, or at least have the ability to access runbooks and documents that'll help you understand what's going on, including metrics and graphs and all that kind of thing, that's also going to help you reduce that TTR. The resolution phase, this is sort of like where you're actually doing some things and you're communicating with your team and you're saying, hey, I think I just found a problem over here, I'm going to restart this service, maybe that's going to fix things. But the resolution phase is a big part of it, and I've got chat ops in here because that's kind of where a lot of teams are going now. They're starting to do these things in chat so they can actually do the thing and communicate to the team and teach the team what's happening all in one step. But the point is you want to be very vocal and share exactly what's taking place. You want to be transparent across your entire team so that everybody knows what's going on. And then finally, we're going to get into the documentation phase. This is where you're going to do your postmortem. What the heck happened? Tell me the story. What exactly did you do to fix it? What exactly, or who exactly was paged? Also, let's come up with some sort of remediation. Are we going to create a runbook out of this? Are we going to create a JIRA ticket? Like, what are we going to do to prevent this from happening in the future? Conduct blameless postmortems. We had an open space on it yesterday. We talked a lot about AWS's outages and what types of things that we can do to kind of, I guess, you can't prevent it, I guess, but help reduce that surface problem for yourself. I'm not going to read all these things. These are basically just all the same tips. The point is there's a lot that goes on when you're on call. It's not just about being paged. So have some empathy for your ops team and your SREs and the people that are actually responding to outages and dealing with this stuff. And if you're a developer, offer to help. You know, there's been a big push lately in DevOps to get the pagers handed off to the developers because they're the ones who understand what's going on with a lot of these problems firsthand. You already know about that, so don't worry about that. We talked about chat ops yesterday. We can do an open space on it today if you'd like. And I think that's pretty much it. If you have any questions about on-call stuff, I love talking about it, and thank you.
Here's where I confuse you all. I'm up on stage, but we're not done. I'm giving it Ignite. So 1 sec. Is it loud enough? Can you hear me? Hi, I'm Dan. I'm Meatball Hat. I'm going to talk to you about something called gap junctions. I read an article like 6 months ago. I forget how long ago. It was easily a month after I got the magazine about these things, and I really got fascinated. And it kind of got me down this path. So that's me, and this is what I'm going to talk about. Gap junctions effectively are our understanding of how cells communicate. So animal cells, not just all cells. There's different kinds of structures that live in that exist rather in plant cells, and things like sea sponges and slime molds. They're a little bit different, but they all communicate in some way. In humans, we can find them pretty much everywhere, except in mobile cells like sperm or red blood cells. But pretty much everywhere else in humans, maybe skeletal muscle of adults, that's another weird exception. But pretty much everything else communicates this way. They're also found in animals. Oh no! Here we go. Crayfish nerves, rat pancreas, liver, adrenal cortex, epididymis, duodenum, muscle, monkey retina, rabbit cornea, fish blastoderm, frog embryos, rabbit ovaries, rabbit skin, chick embryos, goldfish, hamster pressure sensing, acoustic vestibular receptors. Okay, there we go. It used to be thought that these things didn't actually touch, so that when they have two cells side by side, that's where the gap comes from in gap junction. That it was thought that there was, in fact, a void between them. We now know better, thankfully. We know that it's actually composed of hundreds of these little connections where they share all kinds of material. They're actually sharing their cytoplasm between cells. And so it's one of these fascinating things we found as electron microscopy has gotten better over the years. So what these gap junctions are actually composed of are these little things called connexons. I'll talk a little bit more about these in a second, but connexons are effectively these channels where molecules and electrical signals and all these things can flow between the different cells. Connexons themselves are actually made of 6 proteins called connexins. It looks kind of like a flower, and then you twist it a little bit, and it opens up. And then stuff goes through. There's a connexon on each side of the junction. So there's actually hundreds of these. So within a given gap junction, you have like hundreds and hundreds of connexons that form this gap junction through which lots of stuff flows. I totally forget what my next slide is, so I'm going to just wait for it to come up. We're going to be surprised together. Oh yeah, so lots of stuff goes through this. Molecules, simple molecules like this, which is the... This is what is this called again? I totally forget this. Oh yeah, it's an inositol triphosphate, also calcium, and pretty much anything smaller than 485 Daltons, because you know what that is. Also, electrical impulses, those flow through there too. So you have lots and lots of cells lined up, like you'd have, like say for example, in your heart. They have electrical signals that flow through them. A lot of stuff does not go through there though, like DNA and other large proteins like that. So thankfully, even though we have these essentially like a Velcro-like connection between these cells, not everything just flows between them. A lot of important stuff does, but a lot of the really, really important stuff does not. It has an impact on macro processes. This is where things get really interesting. So even though it's all about intracellular communication, these things play out very interestingly when it comes to developmental processes and or like large scale, such as like an organ, like your heart, your nervous system. And this is where we get into cell polarity. So cell polarization is a process that happens on the individual cell level, but the way that it plays out on the the animal scale can impact things as simple as, or rather as familiar to us as say, your guts, or your blood, or your brain, and the fact that you have these cells that are different on one side than they are on the other. It's actually like one side of the cell versus the other side of the cell. It also has an impact. So let's see. There we go. Heart. There we go. So your heart depends on this, not just for like the blood vessels, because obviously the blood vessels have cells that are different on one side than the other, allowing stuff to pass through them, but also because of the electrical impulses. So we now know that heartbeats are regulated by electrical signals being transferred between gap junctions. They also are critical for brain function. So you've got neurons, and this is where actually one of the first places where gap junctions were recognized, where they're called electrical synapses, and that's only because they were able to detect them through electrical detection before microscopy was good enough to be able to look at them. They're also in your retina. So you've got, inside your retina, you have individual types of cells connected through gap junctions, and also bridges across different types of cells to be able to communicate very, very quickly electrical signals and chemical signals. And we also now know that mutation with gap junctions in particular can have really, really large-scale effects. So the slight changes in the ways that the connexins that form the connexons that then go on to form the gap junctions, slight changes to those can have really, really big effects. So I want to talk about how we can learn from nature. And that was my Ignite talk. The end.